Good morning, hello, happy Friday. Hello, KO2 fan. How are you doing today? Okay. I think we got everything set up here. So nothing's really stopping us from getting going. You're doing good. You have a meeting. Well, thanks for lurking, and good luck in your meeting. Let's see. What are we working on today? Today, I think we're finally to the point where it's time to figure out the insertion into our ECS. Now, when I say insertion, like we already have like resources that we're adding. I'm talking about entities. We need to figure that out. So I think we're gonna actually add an entities. And we're gonna do stuff over here. So to begin with, we'll probably just have entities are made up of a bunch of components, right? So we could have a pub struct entities. And we're gonna have components, which is gonna be a probably like a hash map of the type, and then then a vector of those components around it. So I mean that makes sense to me, and we could follow fairly similar pattern to the resource add, except this one we are going to have interior mutability. Excuse me. Okay. I don't know what else we would specifically need. So we need debug definitely on. Derive debug and default. Okay, so what is our list of entities going to look like? So this is where we go back to our whiteboard. This is going to help us. We're looking at a database like this, and if we put this on a side, it becomes, if we rotate this, it becomes a little bit more obvious. But this could be a hash map with one row, like one vector being all of these, and another vector being all of these, and another vector being all of these. So we need a hash map with these as the keys and these as the values. And we can use the type ID as the key again. So we can have, this is going to be the, I guess this will be the components. You're going to be a hash map with a type ID, and in here we're probably going to have a vector of a single component, but this is where I think we have to do RC dyn any for this. Or let's imagine if we don't do this at all. If we just have like it in a box or something. Because I don't think I could have like a dyn any. What did I do in here? We yeah, we have it in a box. So let's imagine. Let's try a box dyn any. So if I just have this, if I want to, let's do our impl. We'll create new first. And now let's do an insert. Okay, so we do an insert, we can do an add. Okay, so we have our, well, no, we need self for this. And then does that make sense? I think we're gonna have a register thing to make sure that the number of rows remain the same. So for example, if we get down, time for us like to add an this one here, we need to register, oh no, this one here, we need to register this next type to create the rows in the database, and that way every single time I add something in, it's a none for everybody else. Is that true? My other choice is to, just when I do add, it does a self register. Flint Rusty, hello. So if I do like an insert in here, what am I drawing? So this is a whiteboard that I'm using for just like planning out and figuring out this entire ECS system. So basically this is essentially the memory locations. What the in-memory database can look like. So when I go to add a new one, so let's say I am adding, what is this website? This is called Freehand. So it's Envision's Freehand. And if you want to play around with this one, I can give you a view only, anyone with the link. Here's the link to this document, so you can come and play around with it. You can't draw on it, but from here you can create a new board, and it'll show you like you don't even need to have an account to just come in and sort of like see other people's. And yeah, you can see your mouse sort of like moving around. It's a really cool software. It's called Freehand by Envision. Okay, so let's say I want to do an insert. So what would that end up looking like? That would be adding, I do have Notion, yes. I do use Notion at work, yes. And I've been using Notion to track my personal tasks as well. It's been pretty good for me so far. I haven't played around with the API. I do want to, because I feel like there's a lot of like fun things you can do with it. Very similar to what you could do with Google Sheets, using it as a database. Okay, so when we insert an entity, so insert an entity. So I want to do a like, if I register, that could like create the row, or I just say like, hey, probably a builder pattern where I can call the same function over and over again to like insert component, and then the rest of the components become a none. That works. Stacking, hello. You use Bear app for work and you find it best for yourself. iPhone and Mac OS though. What is Bear app? I have not heard of it. Bear app, Mac. Oh yeah, that sort of like looks like they're copying a little bit of Notion stuff down, or vice versa. Is it only Markdown stuff? So like references. Oh, no, it's okay. Yeah, that's pretty cool. That's awesome. You think Bear App came first? Like a lot of these things are like sort of hard to tell. You're currently using OneNote. I have tried to use OneNote before. Every time I try to use like OneNote, I like it, but then I don't end up staying with it for one reason or another. Notion is like super powerful, but like as you mentioned, Clint Rusty, you got to have a plan for it. I like the databases feature in Notion though, so I'm like that's the thing I like in the most is I can have like a relational database for everything. And then I've also like played around with Obsidian, which sounds like it might be very similar to Bear App. Well, I have yet to figure out like the full setup. If I ever do that, maybe I'll show it off, like what in general I'm doing. Okay, so let's have like a builder pattern here. We're gonna have like a like an entity builder. So we're probably gonna want something like a pub struct entity builder. Hi. Puppy. Come on. Maybe? He's behind the Hey, he's behind the green screen just staring. Hi. Hi. He's thinking about it. Goopy, hi. All right, we'll see how long he's willing to hang out here with us. Okay, so we're gonna have the different components. I guess does that make sense? If we have entity builder, this almost ends up not being being like an empty struct then. That's just gonna hold like entities in here. Kittens in the attention span of a fly. I agree. He played with the toy for like, I don't know, 10 seconds. And then he's not even in the room anymore. He's gone. Okay, so we're gonna import entity builder. I'm not gonna do new with this because we don't need that. What we're gonna do is we're gonna have add component and then build probably. Because I don't know otherwise how we're gonna do this. We need some kind of like build or end for it. Either that or we have like a new component with type. Okay, so what if I do something like this? We're gonna have a pub function. We're gonna have like a register component with this t. mute self. I actually don't even need mute self, but it doesn't matter. And then the component T. So, you know, I'm thinking there's no reason I need the entity builder. This could just go straight in here. So we can have register component. We're gonna have to give it that T, which, if you remember correctly, it's gonna be that static plus sized. Then we're gonna have mutable reference to self. And okay, so we don't register. Like that's the only thing we do. And I don't know if we care. We can return the row. So like we could return the row, the new ID for it. And the ID would be the row in the database. So like think of it like, okay, the first one's gonna be 0, the second one's gonna be 1 and 2 and 3. So we could do a U size. So we can do a U size. Excuse me. No, I don't want to do U size. I want to do a mutable reference to self, so I can just do like dot. Excuse me. We're gonna do a mutable reference to self. So in here, just gonna start by returning self. And then for this, we need to, for every entry in the hash map, we need to add a new line. So this will now be add empty cell to all components. Is that true? Let me double check this. So if we let's like turn this on a side to make it like maybe a little bit more closer to what we're actually gonna do. So we're gonna have a hash map. We're gonna have something like location. Maybe let's have another one here. So it starts with location, and then that's gonna be a vector. And we're gonna have a cell in here. So this might be something like 4 or 5 is like what this is. It's a location. So this should actually be locations. And you don't actually care what the data is. So this is gonna be just locations. And then we're gonna add another one in here. So this is gonna be maybe like our sizes. We already have sizes. Oh, this could be like colors. So then you come down, become a color. Okay. So we start insert location, and I want to, for every single one, I'm going to add a new entity. And so I give it a new type. Let's say it is this type here, which means this doesn't have anything in here. We're going to find out the length of these other ones and then just add in blank ones all the way across. Actually, that's not completely entirely true, is it? When I add a new one of these, we're gonna find if it exists. If it does, we're just gonna add this to the end. Otherwise, if it doesn't exist, add it to the hash map, and then fill in however many of these with nuns as we need to. But then we need it to add in like nuns for everyone else too. Like, I think that's what we need to do. Because we have the two choices. We could do the register method, where register and we just create all of these, all of the components that we need to begin with, and then we add them in later through here. I'm not exactly sure what like the best way to do is. Last time we did the register method. If I want to do the sort of like ad hoc method as we go through, that may be more programming and like more chances for failure, but I think it leads to a nicer user experience. So we should try that. So basically we start with empty, right? And I'm going to start creating a new entity. So we're going to do register component. No, it's going to be register entity. Oh, but the world probably has a builder pattern on it, doesn't it? No, the world can just extend the entities, which then we can do this with it. Oh, okay. So that's probably what we're going to do. So register entity. We're going to take this type and we need to find out, do one of these exist or not? Because it's possible that we've already done this and they do. So let's get the type up. So let type ID is equal to type ID of this T. Okay, so that gives us this type ID. Then I just want to create the new row if it doesn't exist. And we want to do this first, don't we? Add empty cell to all. Okay, so use self. So we need to do this as well. The very first thing we're going to do is loop through all the components and add a none to these. So I think in our vec we're going to have an option and then a box dine any. Okay. So we could do for component and self to component iter. That I believe works. Yeah, let's do it. Oh, we have this type ID. So we really want we really want iter mute. And can I just do values mute? So this gives us the components, the vector of components for each one of these. And I just want to push in a none for it. So, hey, look at that. Components.push none. So that's it. Like, we now get an extra cell. So as soon as we call register entity, we now get an empty cell here. So register entity, this happens. All right, now we figure out the type. So now, is it a new one or is it the same one? Let's do a get. So if let sum, and this is going to be the components, equals self.components.get. Very close. This type ID. Oh, you need to be mutable. Mute. Okay, so if we have the components, there's really nothing we care about doing here, right? So really, this should be a none. If let none equals get mute doing this, then it's time for us to insert an empty vector, but we also need to make sure it's the size of all of the other vectors. So what if we have this returning the new length? So you return a U size. No, this it feels like a side effect. Feels like it's doing too much. We should just get like the count. Oh, we can do okay. We can just store this outside of here, right? We can just do the number of entities. So entity count is a U size. I believe default is always 0 for these. So then coming down here, we're going to do every time that we add an entity, we're also going to increment self.entity count plus equals to 1. Then okay, so then and there's this thing where we can just do, we don't have to do this if let none. I can just do dot is none. Okay, so get that if you're a none, we need to insert a new vector, but have it be the certain size. So this is gonna be super, super close to what this is. Self.components, insert. We will do this type ID. And then we want a vec of none and the self.entity count as the number of them. So that should now add us a new row. So we want to add in, you know, something else. What's something else? Like maybe health. And we just did that to it. Okay, so that's good. The trait bound dyne standard any standard clone is not satisfied. Required because the requirements the impl standard clone for box standard any. Oh, okay. So I can't actually do this style with it because it's trying to clone the none. I would think that clone would work with that, but I guess we could just do this separately. So add component. I guess in this case we're gonna have a T, which is the static and sized. And I don't think we're gonna care about everything else. And I don't think we need to return anything. So we need to create the vector first. And apparently we need to do it manually because this doesn't work for us, which is unfortunate. Well, I could make sure, wait a second. Could we make sure that this also implements clone? One redundant, okay, so. So I guess dyne any doesn't implement clone. Oh, that's too bad. Okay, so never mind. I can't do it. All right, so down to this again. We're gonna need to first create our vector. So let components. We're gonna start with an empty vector. Make you mutable. Then I want to count until this. So I don't actually care about this. So in 0 ... self entity count, and we're going to do components push none. Okay. Once we have that, we're going to get our type ID. We already calculated our type ID, so maybe instead of this, we're just going to pass in the type ID. Is a reference. No, we need ownership of the type ID. So we're going to do self.components and insert type ID and these components. Okay. So in here. So if you're none, we're going to do self.add component and give ownership this type ID over. Okay, that's if it's a none. If it is a something, it now has like an empty space for it, and we have the entity count should be the last ID minus one essentially, but it's gonna be the last one. That's all we really care about. But okay, this is for register entity, and then we're gonna want to do something like with data, like with component, I guess. Full first dad, hello, good morning. Today is a day to be celebrated. Well, that sounds good. I'm looking at my calendar. I don't see a holiday or anything for that. So what's the celebration? You got into your dream university. In 7 weeks, you're going to be studying for a master in biomedical engineering at the Royal Institute of Technology. That is great. Congratulations. Awesome. That's going to be so much fun. Hello, Oscar Ellen. Okay, so we need that T statics and sized. So this can be the right for each one. In this case, I don't need the T actually. We're just going to start here and do mute self is coming in. Oscar, you got your master's there. Oh, well, congratulations. Then I don't need to pass in the type ID because we're going to figure that out from this component. So this is really just going to be something. This is going to be the component, which is going to implement any. And we're going to return a mute self. So we can start with that. Sadly, you can't be in uni all your life. That is a true statement. I do know some people who are like practically professional students who have like 4 or 5 degrees. I know one person who he has a master's in engineering management, and so he feels that he can now claim with definitivity that yes, programmers can be called engineers. And he has the authority to say that, he claims. I think it's hilarious. Okay, so with components, we have this. Okay, so now we're gonna we need to get the row, the specific row that we're looking for. We need to get that array. So in this case, it's gonna be, so with component, we need to get the type ID so that the type ID is gonna be equal to our component dot type ID, right? Okay, that gives us that. Then we're gonna have to get the vector. So let components is gonna be equal to self components. Okay, get that. Okay, that gives us this option. Let's have you return a result with this mutable self inside. And that way we can now convert this option into an error in the case that it fails. So we're gonna do if let sum components equals u. Now, if there's an else, I am just gonna bail, and we're gonna say we could not find components to insert into. If we do find it, we want to components push box new component. And I believe that's exactly what this is. We're gonna do, oh no, not push. So we're gonna do components. We're just going to overwrite the last one of these. So is there like a last mute? Oh, okay, so I think that works. We're gonna do that last cell equals components last mute, returns a mutable pointer to the last item in the slice. So then we're gonna do a last cell is equal to this component. Can I not do that? Cannot be dereferenced. Oh, and you would be a sum. And you'd be a boxed. I don't know if I'm actually getting access to this the way I'm expecting to. I don't think I am. Oh, okay, so I want to do, okay, I need to do that pattern. So hold on. If let sum so this is really a last component is equal to this, then what we could do is this dereferenced last component is going to be equal to, I don't have to, oh I do, you're still going to be at, okay, you're going to be a sum box new component. I think that works. Yeah, like not super nice, but it works. So if I do set something with the same one over and over again, it'll be just setting the same cell over and over and over again. Okay. And then I think that would be it, right? This is just going to add them all in. So if I want to test this, I'm going to have a we're going to test adding components or adding entity, I guess. Okay, so first of all, we need these entities. So let mute entities. Okay, that looks right. Then we're gonna have to register an entity and we have to give it a type, which means we need a component to add in. So struct, let's call this a doesn't really matter. This could be a size. And we'll have you be like an F32. So this will be a component. Then entities, register entity. And then we could pass it in this type. So self dot register entity with our size like that. And now we can do dot, and then we're gonna get with component. We do size of like I don't know, 10.0. Why are you self? This should be entities dot. Okay, so far this seems to be working. So if I run this test, okay, it runs and is happy. Hello, hi, hello, Zippy. It's up. It's up here. Will be. Come on. Oh, Oscar Ellen redeemed Pet the Kitty. I don't know how petting mood he is. Doesn't look like he's in petting mood right now. But we'll try until he gets upset. He's mostly just ignoring. All right. Okay, so we can register this component. We can register an entity with component. This actually, I don't think this is gonna work, right? Because let's say I have another one here. So we have like a struct. We have a struct. We have a size. We have like, let's say we have a location, right? So we have a struct location, and you're gonna have, yeah, F32, F32, something like that. In this case, I would want to do it with a component of location. Sure, that's all fine. The problem with this, obviously, is, well, I didn't create the location here. Like we're only doing that register. So register should just add, I don't need this T at all. Like that's completely useless to me. I don't need this type ID. What we need to do is increase our entity count, and we need to add a cell to all components. So that's fine. This doesn't happen though. We're just gonna add a cell, empty cell to all existing components. And then return self. Then with component, we're going to take in our component, which implements any. Then we can get the type ID from this. And so here we can say, if, like, okay, now try to find the vector of these components. If we can find it, let's get the last one, and then we will we'll insert the component in. So that's what's happening here. If we can't find it, instead of cannot find component, time for us to instead add a component, add this component in. So we're going to do self dot add component, and this could be our type ID, and that's let's see. If I do that, I then want to like add this component in here, don't I? And probably something like this. Let's see, maybe. Because here we're doing, okay, components. Now, I would imagine we can do something like this. Go until -1, and then we want to push. So components.push, we're gonna bring in the component here. You're gonna be a sum of a box new component. And then we're gonna insert you in. So then the last one goes in. And then components. Okay, so we got a vector of option of box. Impl any instead of dine any? Really, but shouldn't that do it? The component impulse any. I mean, I could just box dine any. But yeah, there's some box new component. Over here, we're doing a some box new component. Huh. Shouldn't that be the same thing? Rust Analyzer, are you screwing up with us? Also, this can't fail anymore, so we don't need this result. We can just return this. So we just do this. Okay, so now I don't need this anymore. We just register entity. So if I run you, what happens? What? Okay, let's actually create a terminal here because weird things are happening. so ECS, I want to run cargo test. Okay, so that actually is a real error. Hello, hi, welcome back. Hi. No, you don't want to hang out? Okay, expected new entities found enum result. Okay, so this is entities line 39. Oh, right, because you're now just a self. Okay, that's the first error. Okay, expected. Let's just try this again. Okay, so expected trait object dyn any found type parameter impl any. That's interesting. So I don't understand why that would yell at me here. So this component. Oh, do I just need to say this? Here a vec of option of box of dyn any. Is that all I need to do? I think that's all I needed to do. So then here we can run this test. Or not. Everything passes now. Okay, so yeah, that's weird. I have to, it couldn't figure out what the type was. That I wanted it to be dyn instead of impl. So that's a thing. But now I can add as many components as I want, and they should all be the same size. So let's double check that. Let's at this point do a quick. I don't think I can do like a debug. But we can assert, right? We can I want to loop through all of these, all of the components, and like get the sizes for those. So we have access to the entity count. Okay, so what we want to do is for components in entities dot components dot values. Okay, that's fine. Then I want to assert equal that components dot length is close, but not exactly. So assert equal components dot length is equal to entities dot entity count. So make sure that they're all the same. To passed. Okay, that's awesome. Now, getting them out is like the toughest part, right? We want to query for these components. So give me this is just adding entities. We can create another test for this. Function test querying So in this case, we don't need these results. It cannot fail. So we're fine here. Let's hold off on the result until we like absolutely know that we can't do it. Okay, so the first thing, we're going to create the new entities, and I'm going to throw these entities in here. So we create that. Once we have that, I want this entity back. So we're going to do some kind of query, and I'm going to want I guess I'm going to have to give it like the type ID. Give me everything that has like the following types. Give it, and it's not like the full entities that I care about. Give me just the give me a vector with a reference to the components that have each of these things. So what I mean by is, let's say we have like a bunch of these now. Okay, query for everything that has, here we'll just like repeat this over again a couple times. I want everything that has a location and a color. So that means I want these and these. I want to skip that. Although we could just pass it in with a none, and we just want to get both of these out. Perhaps that's what we do, and it's just as simple as possible. And perhaps that's all we care about. So we need to find, and this is where the bitmap comes in. Because like, imagine if we have a bitmap that has for each entity, so it would be still using type ID. It would actually be exactly the same as this, except without the data inside. This is just going to be the equivalent of like a 1 or a 0. But instead of storing them as like a vector of 1 and 0, because that's inefficient and like requires lots of loops. Okay, apparently I can't. We store this in a binary number, which does limit us to the number of entities that we can have. But I think we can go all the way up to a U1. We can go up to U128, so we can have 128 of these if we do this system. So if we just look at this, we have 1 0 1 1. That is a binary number, 1 0 1 1. If you've never played with binary numbers before, the way this works is we have is it zeros place? No, it's 1. This is the 1 position. This is the 2 position. This is the 4 position. And this is the 8 position, and so on all the way up. So if we have a 128-bit number, we'd have 128 of these. And it might just be 000000001 all the way down. But this is a 4-bit number. And so if we look at this, we just correspond, okay, this is 1, 1 plus 2, so that's 3, plus 8, that's 11. So this would be represented in decimal 11. And it would be unique to show that we actually want to do it vertical, right? So we'd want like this is 2, this is 0, this is 2, this is 2, because they all each have their own. So let's think about that. A bitmap would be just a vector for each component with the IDs in there, and we're looking for so you'd be 2, you are 0, you are 2, and let's like update this. Maybe you don't have a color. You have a location but no color. In which case you're a 1. So this way we can do a bitwise operator to determine what to give us back. If we're querying for everything that has both a location and a color, that means we want the 2, right? We want everything that has like a 2 here. And we have to track like that this is 0, 1 and this is 1, 0. Actually, this would be 3, wouldn't it? These would be 3s. This would be 1. Yeah, I had it wrong. So I'm gonna do bitwise. Give me everything that has location. Give me everything that has a color. So when I query, I want to pass in the types that I'm querying for. So let's actually create another entity. So you have size like 11, you're 1, 1. I can even do one last one because this is kind of important, and you don't have a location. You just have a size. So you're 12. So now I want to query this out. Let's say I want to query just for things that have both locations and sizes. So that means I'm going to want a vector coming back with only those 2 things, and I don't have to worry about anything else. How would that end up looking like? I want to pass in, I can pass in the types of these. I'm not sure how to go through and like choose those. So I want, this is entity 1. This is essentially a deleted entity. This is entity 2, and your entity 3. So I want to query for essentially entity 1, everything that just has these 3. So I'm going to pass in both the types IDs, or the types. I'm going to pass in the types, and that's all I care about. So I need potentially like a query struct, a query builder, so that I can build a query of like these different types. So I would imagine that if I had something like that, like query equals a vector of these two types. So we have like size. Oh, it's gonna be the type. It's gonna be the type ID. We're gonna have a type ID of size, like that. I think it's like that. And type of location. So I want, if I do this, that's great. How do I know that location, that size is first? So size is like the far right, is like the 1. Our bitmap is going to be about entities. Our bitmap is of entities, but also like for each entity, we're going to have like 1001, right? So that the order of this is important too, because this is like 1, 1, 0. Because if I did 0, 1, then I wouldn't be able to like determine that, because that's the wrong value. I need location essentially to be 1. So I need to store that away so I can properly build what this is every time. And when I query for this, we're going to take in those type IDs, and depending upon the type ID, I need to turn it into a number, and then we can do the bitwise operation on that. So I believe if we come to you, I think that we can do a bitwise operations can be pretty simple. We can say, like, let's say we have our entity is going to be equal to, it's a U128. So you're a U128, and you're equal to 3, which means you have both 0 and 1, which I believe I can actually go like this, right? I can say let's do U8. U8 is gonna be a lot simpler for us. So I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8, B. Or is it B at the beginning? I think it's B at the end. So you're absolutely nothing. And then let's debug. Map entity. Is it? Is it B at the beginning? No. Well, what's the way? What? How do you create the binary number? I want to use the B thing for it. Is like, it's not semicolon, right? Is it Oh, wait. 0B. I think it's 0B. Like that. Okay, so this is 0. So if we put 1 in here, this becomes a 1. If we then say you're a 1 also, that becomes a 3. And so we'd be saying, okay, these are locations, these are sizes, or vice versa, it doesn't matter. But we have to associate locations, size. So this isn't gonna choose how many, or stop us from having like n number of entities, just n number of components. So at this point we'd have a maximum of 8 component types. We can have as many entities as we want. Now I can do a bitwise operator by doing I think it's and equals and then essentially 0b, or I can do like 2, right? So which is this one right here. So that would be zeros all throughout this, or to make it more appropriate, I can do that. Like, is this true? It should be true. Oh, is it just and? Flint Rusty, hello. Do I play any games? I just finished a playthrough of Tyranny, which is a CRPG. I did not stream that because there was too much talking during it. Like, it would have there's too much text that wasn't read out. I might play some games in the future. I have to decide like what the next one I want to play is. But yes, I do try to play some games. I am not that great with them because I took a very long break from playing any games. Is it and? It's not and. Okay, so I need to go re-look up bitwise operations. I don't know where to go find that in the Maybe operators? Yeah, I don't know where to go find this in here. So we're gonna have to go look it up. And actually nope, you. Here it is. Okay. Bitwise and bitwise OR, and then XOR. No, that's not what I want. I want Rust playing bitwise. Okay, here we go. Bitwise and I don't want to do that. Okay, so let's say in here we just do this one. I'm debugging. This doesn't show me. Okay, what if I do like this? Oh, it's showing, okay, which ones match in here. I think that's what's happening. Because if I remove this to 0, it should be 0. It should be 0. Okay. Which ones they have aligned. So what I can do is we have locations, we have this, you have a location and you don't have the other one, and then we can look at you and say like, okay, together you have the bitwise and is a 1, meaning that you have one of these, like just the ones in the ones position is matched up and is the same. You both have 1s there. So because of that, if I know that the 1 position here is a location, then I know that you have a location but nothing else. If you have 2, I know that you have a size but not a location. And if you are 3, I know that you have a size and a location. Hello, Stacking! You come back and we're working on bits. We're trying to do the bit mapping stuff. We're trying to build this in from the beginning. And I'm trying to remind myself like how this all works. Because like every time I do it, and like I watched Utspi's sort of like description to me, and like I had like a bunch of notes and everything. I was like, oh yeah, I'm confident with this. And it's like, no, I shouldn't be confident with this. The big thing that I constantly forget about, or like am not sure of, is how do I associate locations with the far right and colors with the far left, or does it matter? But I think it does, right? Does this mean that I shouldn't be using a hash map to store these, but a vector? or another type. There's a hash set. There's other types of hashes. Let's go find collections. Where's the collections? So we have the hash set and B tree set. A B tree map. You want a map sorted by its keys. Oh, do I want a B tree map? Because if I do that, then the first one becomes the one on the far right, and then the second one added becomes the one on the next right, and that becomes a little bit easier for me to like create our. Or we can maybe build it out as we add these. So like the location was the first one that got added, and so inside of our struct we can store. We can somehow store the map. Would you even have keys if everything is stored in a byte? Well, everything is still stored. So everything is still stored as they are. What I need to know is like we're querying to get to very quickly get which components across here. So we're using type IDs as the key here, and then this vex option box dyn any. For I haven't gone to interior immutability yet. We might need to. I'm gonna see how far we can get without it. So let's say I want to query for everything that has a size and a location. So I create these, a vector of type IDs. So that would give me essentially a 1 and a 1. So 1 1 0 0 0 0, building from right to left. If I do a new query, do I have to store everything else? I don't know. So like, let's imagine we create a query here. So we have a query. We're gonna mute self. Let's say that we're just doing query. So we just do a reference to self, and then we want the components that we're gonna query for. So let's even imagine that we can do this as like T and T. Where T is sized plus static. I forget how this works. Oh, I think I just have to do these both in here, right? Okay, so I do those. We get a reference to self. I don't really care about that. We're gonna return a, probably has to be like an option because it could be none, right? So an option with a vec of vec. Oh, actually it could just be an empty vectors, right? So like we might not find anything. So it could be a vec, but then for each of these vectors as we go through, the vector goes down, and then we have like these vectors in here. So then a vec of a reference to a component, so that would have to be this like dyn any, like a box dyn any. Something like that. Oh, so we could have like two of these. So we have A is also static plus sized. So like we're looking for both of these. So I have these results, and now I need to find, give me every entity that has both of these. It should be U to U. Would it make sense to do this like A, B? Like that? It might make sense to do this as like A, B. TU. Okay. What's the reason for TU? U is after T. And then if I have a third one, and then a fourth one, and then a fifth one, and I go up until like we have 20 or 30. So if I do this, we're querying for both of these. It was in a book somewhere. Okay. Well, if we're querying for one only, maybe we should just like simplify further. Let's do this. We're gonna do a query with a T for this. Okay, so it's just one. And we're gonna return this vector of vectors. So like all of our queries are like this here. So if we do this, we're going to get the type of, okay, so let's get the data type, the type ID. Okay, so if I get the type ID, I need to figure out if you're if you take in T, why aren't you having vec of T returning? Returning any is really anti-rust because I don't know what type it is. But I guess it could be T, yeah. I don't know if that's right. Okay, so I need to figure out who has this type. So for our bitmap, which I did the bitmap wrong the first time. So I can't actually use that bitmap as like an example and like go back, look through it is because that's incorrect code. So we should be having like a bitmap inside of here. So we need a bitmap. You're going to be a vector of, let's say like U128s. Defaults can be fine. I suppose we also, okay, so I think what we need to do is for every type, we need to have maybe another hash map or to register that it's like this thing, right? So locations. What am I storing in vec if I need a U128? If I had a U256, I would use it. Come on, CPU makers. Let's up our CPU so I can use U1028. I want it. Give it to me. Imagine the people in the future like are gonna have access to U1028s and I don't know 50. See what is it? 2024s and no, the 2054s, and they're gonna be like, how did you ever program with only U128s? Jeez. 64K. Who needs more than that? Of course, yeah. So if we start with location here, this is gonna be essentially like 1, 2, 3, 4, 5, 6, 7, 8. So locations is registered to that. Look, colors is gonna be 1, 2, 3, 4, 5, 6, 7, 8. Is gonna be this. So I think I need to have a lookup of this, of like the bitwise for this, so I can build up what the number that I'm looking for is. So that way I can then test to see bitwise and does this match up? Does this match up? I don't know how else I would do this. if I was to do that, we would have our bitmap is here, and then we have like to have our like the bitmap, the bitmaps. Is this the bit mask versus the bit map? So you'd be a hash map with type ID, and then this would just be a binary number, so U128. When we, with component, with our type, if it doesn't exist in here, so add component, we're gonna have to add in like the next one in here. So then we also need like a last used to figure out what the last used number, because it doubles, right? Like 0, like 1, 2, 4, 8. So I think I also need to store in, oh no, it'd be the count. It'd be the number of components. It'd be the number of components. Would the first bit always be the type of? All of the bits would be the type of? What I think we can do is get the length of the entity count, or the length of the bit map, and then plus 1. And that gives us what this is going to be. So I need to know that, like, for example, let's say we're using U8s instead of U128s. The locations would be represented by 7 zeros and a 1. Colors would be 0, 0, 0, 0, 0, 0, 0, 1, 0. So in decimal, this is what? 2, and this is 1. And this is all so that I can then say, okay, I want everything that has locations. How do I know that it's like this? That is the number in a far right. That's a bit in a far right. I think that's what I need to do for this. Because then when I do the query and I say, hey, give me everything with the locations, we're gonna have like a vector of these. This is our we have the bit map and we have the bit mask, right? So we have a bit. I guess he decided he wanted to go into the top of the closet. Back in your college days, we did an enum for the bit mask. Then the first bit would be the type ID, and then the rest of the bits be the data. So an enum for the bit mask. Okay, well that was not very long. Hi. The end goal is I don't want to have to do like many loops to go through and check to see if we have a none or a sum. So your bit mask would be location and color, right? Yes. In this case, yes. And if I add another one, there'd be like a third one there too. Yeah. So for example, stored in here, we'd have you're a 3 because you have both the location and color. You're a 0 because you have none. You're a 1 because you only have location. And like, okay, we could have maybe here, how about this? You have a color, so you'd be 2. So if I want everything with both locations and colors, then I only want to get this. I don't want to get entity 2 or entity 3. So that would be a bitwise AND operator for these two, right? I would take okay, I'm adding in location. Oh, and I think bitwise AND is even easier than that, right? Because if I do, let's say, instead of like map entity, let's do this here. This would be let's do let mute bitmap is going to be an empty vector. Then we're going to say, okay, let location bit mask is equal to 0b 1 2 3 4 5 6 7 8. So you're 1. Let this is going to be maybe like size. Two, 3, 4, 5, 6, 7, 8. So you're that. Now, okay, we're coming in here. We're creating a new value in this array. So we're gonna start with we're adding a new entry into here. So we're gonna say bitmap.push 0. So starting in, you have nothing in there. Then we add in the location. So we give you a location. So we're going to say bitmap of position 0. So we know what position it is. We're going to do an and equals to location bitmask. And hey, we're also going to add in a size. So we're going to do bitmap of position 0 and equals size bitmask. And then at the end here, we can take a look at our bitmap, and it should be 3. It's a 1. Great. I thought that was gonna add it in. Does this not? Do I need to do this? I thought the bitwise and assignment. Okay, that's what I thought. Variable equals expression. Okay, hold on. So is it or? Oh, it's or. It's or. Okay. So or, it's now a 3 in here. So now we can see that we have both of those. So as we're adding these in, so okay, we need to store in what you are. Wolver's adds here. I mean, there's many potential reasons for that. Is he driving right now while he's in Discord with you? Chatting on Discord through text and not voice? So I think this is what we need. So we need a map for this. Is what we need. Is we need this map to determine that, like, hey, you're this one, you're this one, something like that. Yeah, that's not good. That's not safe driving. Yeah, I remember hanging out with people that did that. So then this bitmap is gonna be, we're gonna have the type ID and then this number here. So at least the Red Bull ain't a beer, so he's got that going. Okay. So this is what we need to do. Every time we add a component, if the component exists, then we also have it in our bit mask, our bit map. I guess our bit map. So then we need to figure out, we need to get which one of those it is. So with component, okay, the component exists out of components, which means the bit mask, the bit map should exist. So we add this, we add the component in, that's fine, but we also now need to get the binary number representing the this like type of component. So let bit sort of like bitmap value. It's gonna be equal to self.bitmap.get with this type ID. I mean that's fine. That should be fine. The I can actually probably just do unwrap or default. This should be fine because like we should never actually run into this problem. Okay. And then the most recent bit mask. So, okay, so register entity. We want to also then say self dot bit mask dot push 0. Then we're gonna do self dot bit mask dot last mute. We can unwrap because like that shouldn't be a problem, and then or equals this bitmap value. Oh, hold on. You're a dereferenced. I mean, so if I do this, so last mask equals to you. Then we're going to do a last dereferenced last with mask or equals bitmap value. Let's just unwrap because I don't think we could run into a problem here. I think this works. But we're missing, if we're adding a component, we need to like now push in like the new bit mask for what that's going to be. So we have our type ID coming in with the type ID. Type IDs implement clone. I don't know. Maybe it does. Maybe it implements copy. I don't remember anymore. So then I want to see if I want to add this in. I'm gonna say self dot. Okay, so I'm gonna add a new entry into the bitmap with the type ID and then U128 to figure what the new bit mask is going to be. So let new bit mask is gonna have to be it's take the length and multiply by 2. No, it's not that simple. It's to the power of 2. Length 2 to the power of the length. Okay, so it's gonna be like 2 U128 dot pow of like whatever the length of this is gonna be. So that's gonna be self dot bit mask bitmap dot length. And I don't know if I need to do that. That you might be able to figure that out. And then that gives me the new bit mask, and then I want to insert this in. So then we're going to do self dot bitmap insert type ID new bit mask, like that. Oh, even though you could figure it out, you can't right now. So I'll just have to give it a specific type right there. Expected U32 found U size. Okay, so as U32, that should be fine. So that adds that in there. So I should be able to do an insert with a bunch of these. And before I even do the query, I just want to debug the entities. Just that. I just want to see what we have in here. Can I actually get that? No. There's a way to do how do I get the console log out of there? Yay Mukund, hello. Why would I use a bitmask over, say, an enum or a struct holding enums pools? So I have like an option, which is essentially an enum, for in each of these, so we can have like none and some of it. I believe what I want, like the reason why I want to use a bitmask for this, is when I query for, I want everything that has location and color. I don't want to have to loop through everything to then determine, okay, should, like, do you have something in it or not, and do like a lot of equality. Last time I did that, we ran into a ton of performance issues with, specifically with deleting. That was like really, really, really harsh. If it wasn't that, then I don't think we would need to use it. So essentially, we're doing both a bitmask and an enum, so with options in there. Yeah, that's the only thing I can think of. Is like, that's the main reason for that. Oh, and this is a bit unfortunate, but in 5 minutes I have a meeting. He could cast an enum to a bitmask, which will help when he adds more stuff later, which is what I suggested. Cast an enum to a bitmask. I don't know how to visualize that in my head. Or I'm having trouble figuring out like what that would look like, which is maybe why I didn't consider it. Stacking, if you know what that could look like, or you have an example of it, could you send that to me? Also, could you send it to me on Discord, because I have to do an emergency stream shutdown. It's been a while since I've done this, but I have a meeting in like less than 4 minutes. You have never had to work with bitmask. This is very much the perspective of trying to learn. Oh, yeah. So I'm very new with it too. Utsby helped out a lot as well with this. He gave me some examples, and which I did not keep. I told him that I wanted to like learn it and like struggle through it to like truly learn it. So that's why we're here and doing this. Anyways, I have this meeting in a few minutes. I'm so sorry, everybody. I'm going to do an emergency stream shutdown. I'll be back on Sunday morning to continue working on this. And so with that, I hope that you all have a great rest of your day, and I'll see you all next time. Bye.